Guys, you're welcome to the concluded part of this awesome application. We'll be looking at the dependency injection. We'll be talking about the view model and a lot of focus into the repository. We'll be looking at the forecast repository and the network bound resource. Without much ado, let's get started. For us to integrate dependency injection using Dagger into an Android application, you need to create a singleton app class which sits out of the file tree. You could sit just close to the main activity. We have this as weather app that extends application and implements the as activity injector. You will be actually instantiating the app injector using the app injector init in line 28, and you could also trigger Timber for getting the debug or getting the kind of error code and things like that, just like a log. So you can also use Timber for that. And you need to call the dispatch Android injector since you've implemented the as injector. This app injector is very, very important because it's just like when you're starting your application, something gets triggered firstly, even before the launcher activity. And you need to include this in the manifest. Right there in the manifest, in the application tag, you need to write the Android name pointing at the class of the initialization, which is called weather app. After completing this, you need to create a class called app injector. You have to make things look so organized by creating a package called DI, which simply stands for dependency injection. And you could start to write classes that are related to your flow. Firstly, you need the app component. You need to actually get the components needed, which you don't need to repeat yourself. The essence of an injection is you don't need to instantiate classes all over again. Once you've instantiated it once, you should be able to use the objects throughout the lifecycle of the application. It has a tag of components where you're going to pass in the components used. We're going to be using the Android injection module, the app module, and the main activity module. So you need to put them right there in the module objects. So we'll be creating classes that's related to that. The interface app component now has a builder where you're going to build up the components class itself. And you'll be injecting the weather app, which is the singleton class you created, and also save it as the name in the manifest. The app injector is going to do a couple of things. It's going to help you to build up Dagger app components, and it's going to help you to register the activity lifecycle with its callback, where you need to override the on activity created, started, resume, pause, stopped, and even save instance state with the destroy, the basic lifecycle of the app flow. And you may need to undo the activity as well, probably when you are replacing fragments or when you're trying to get an instance of the fragment itself. That's very important because you've actually instantiated the app injector in the weather app class. Now the app module now gets drilled deeper into the app itself. What will you be needing in the app module? You'll be needing the retrofit service. That's how the retrofit call is being made, which you could actually add the header, and if there's an header call, or you could pass in an API key at the header. It depends on how the API is being set up. You could also add the interceptor, the OK HTTP interceptor, that is actually helped you to log all calls in the logcat. That is very handy for debug purpose. so that you get to see the calls that you're making, and it shows in the logcat. You need to create a retrofit instance, which should be once because you might need to reference your API at any point in time in the application. At the same time, you need to access the DB, which is the internal database, the SQLite database, which is called in the Room database builder as well. Not only that, you need to actually interact with the database using the data abstract objects. So these are components which are categorized in the app module that you'll be using in the course of the application. You have for the fragment builder, you have multiple couple of fragments you'll be creating since you are using the Android navigation, so it's compliant to use fragments. You have for the today, weekly, and settings. So you need to declare that as well in the injection. The injectable interface could be left empty. And now the main activity module, that's for the main activity itself, since it's an activity, which is the launcher and is actually housing all fragments. You need to also be aware of the view model key and the view model module itself, where you're going to be binding the forecast view model and also bind the view model factory. When you set all this up, because you'll be needing some other components out of this, you can now build up your application and have the Dagger component activated. Initially, when you set this up, you're going to have this as red, telling you error. But when you build it up, it's actually going to be fine. And your Dagger app component will be alive for use. Let's look at the repository, because this is where the network calls are made and even the save to the DB. If you notice, we are injecting the DAO, the weather service, which is the Retrofit API call, and even the app executors that will help us to save database data asynchronously and using multiple threads. We're going to load forecasts, like fetching, and it's going to return a saved daily forecast, which is a list of resources and also of live data. You need to pass two parameters, the city and the number of days, since the constant of the app ID has been established. And you return a network bound resource, because it could actually crash or not. It could return different status code. It might be 404, it might be 403, and it might be successful. It might even be 500. So you have to actually handle that correctly. In the save call request, that is where the whole stuff gets started. You're going to actually get an item, and this item, you need to call the get daily forecasts. You test if it's not null, and at the same time, you extract its values by looping through the daily forecasts using the for loop here. In there, you could extract the value, and we are trying to save it into a new list called saved daily forecast. So the values generated, the time, the morning, and what have you, will be saved into a new list, which is of a saved daily forecast generic class. Now you could ask, should you fetch? You fetch when data is empty or when data is equals to null. That's cool. You could also load from the DB, calling the DAO to load the forecast. That is if data is available. And you create a call. These are what you must actually handle. The load from DB, which is from the network bound resource. You load from DB, you fetch, and you create the call. When you're creating the call, you'll be passing the variables the city, the number of days, the constants of the unit system, and even the API key. Those are the values that the retrofit call actually needed. The same thing is applicable for the fetch forecast. This is just a replica of the previous one I mentioned. So that one goes straight to do a merry-go-round through the internet to fetch data, while the other just hits the DB without fetching from the network. That's just the difference. We also need for fetch UVI too. When you have the lat and long, you also return a network bound resource, which is going to override the same method I mentioned, the load from DB, and create a call with taking the lat and long inclusively with the API key and fetch the required data and return it to the calling method. So the forecast repository is a standalone, and the network bound resource actually makes the call much more scalable. So all data are fetched through the fetch from network. You could even set value, probably if you have a mutable array list or a mutable list. You could save the call request. This is the should fetch. These are all methods that you have to override in the forecast repository, and you have to undo the contents. So that's just the basic thing. So the forecast repository is handling the fetch from network and also saving to the database. You don't have to do that in the main activity. Now, how will you be able to access this repository? You get to access it through the view model. You have the forecast view model that the repository is injected, so you don't need to initialize the repository here. And what is it going to do? It's going to call the forecast repository fetch forecast. So I'm passing the necessary parameters. The same thing for the fetch UVI. So the UI classes will be interacting with the view model. In turn, the view model will be communicating with the repository, and the repository will decide the source of truth. Should I go to the database? Should I make a network call? And what have you. It depends on your use case. So that's basically what the whole MVVM structure is all about. The same thing for the UVI view model. You could also have a factory if you need to pass in some constructor values. Now let's get to look at our views. This is the basic. The main activity, which is the entry point, we'll get to actually tweak things. We have the drawer, and we also have the button navigation. So we need to actually make them compliant so that they will actually listen to the navigation class itself. So you have the nav controller, which is actually setting up that with the app bar configuration. And we need to actually undo the last component, which is the share. What are you sharing? So that's what this is actually doing, to undo the share. And you need to undo the on support navigation up. That's the up button, which will actually take you to the previous fragment. The on navigation item selected, the on create options menu, and the on option item selected. You should be familiar with that by now. Now let's get to look at the UI. We have the settings, today, and weekly. For today fragments, that's basically just going to call the view model and actually make the fetch or make the call. Look at it here. It's calling the view model provider, and it's calling the fetch result, which is going to actually interact with the repository, and it's passing the city and number of days that we're getting from shared preference, which the settings is actually going to make that available for you. It makes the call and also utilizes the results over here. Based on the type of condition or temperature, it brings up the kind of image and the text. So that's just it. The same thing for the fetch UVI. Now for the weekly, we're going to use a recycler view to list out the days that we are looking at. The same view model will go, but this time we don't need for the first index, which is 0. So we need it for the other one. Now the first index will actually show on the dashboard, but for the list itself, we need to remove the first index. If you notice, look at it. Adapter, remove item 0. Let's get to look at the adapter to see, because you need to call the notify item change. The notify item removed at this point in time. So you call the notify dataset change in the forecast, because we were trying to remove an item from the list, and we still want the adapter to notify, to be aware of what is happening. That's basically what is done here. So I'll implore you to look at the source code, which I'll be sharing in my description. And at the same time, I would like you to subscribe to the channel so that I'll be able to develop more robust application. We'll talk about Kotlin, and we could even dive into Flutter. Don't go anywhere. Let's see how the application looks. Look at it, looking so beautiful. Lagos, we could actually set that. Presently, we have the broken clouds, and then it's up to 25 degrees Celsius. If you look at the UV index, 14.35, a little bit moderate or high. The wind also 3 kilometers per hour. Let's get to do some settings here. Let's change it up. Let's give Parry. Okay. Immediately it fetched, and we could actually see it. Presently, Parry is of 4 degrees Celsius. It's in the afternoon. And the UV index is 2.67. And also the wind, 7 kilometers per hour, while the humidity is 54%. Let's get to look at the weekly. If you notice, today is Friday at the point of recording. If you should look at the date, Friday 19th March. And it starts from Saturday over here. Sunday, Monday, Tuesday, Wednesday, all down. So it's actually excluded the present day in the list, but you could see it on the dashboard. So thank you very much for hanging out with me throughout this video, and don't forget to subscribe to the Larry Studios. Bye bye for now.